I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll discuss sine law and cosine law. We'll take up real life situations and solve problems. We'll also derive the sine law, see the conditions where it should be applied. There are two situations where in a triangle you cannot apply sine law. These are when three sides are given to you and when side included angle is given to you. Our approach, engaging minds, it helps for overall development. In this video, we'll actually start with derivation of sine law, understand conditions, solve triangles, use cosine law, and take up application problems. We'll see how to solve these questions that will develop both mathematical and social skills for the students. Gain confidence, get ready for the future. Gift of education. I can be part of your success story, build strong foundation, ensure bright future. Contact me on the email address, join my classes. Now, let's enjoy the lesson with Rohan. Hi Rohan, how are you doing?
I'm good, sir. How are you?
Very good, very good. So Rohan, today what do you want to do?
Sir, I would like to do like sine law and then seeing how that goes when it comes to
Sine law.
trigonometry or even in quadratics as well when it comes to finding the curve.
Oh, okay. See, I'll just pull out a whiteboard and then describe to you what sine law is. Is it okay?
Okay, sir.
So, till now, you had been working with sine ratio. Let's be very clear. You did ratio, right? Sine, when you say sine theta equals to some value, let us
Yes.
say half, right? So, in that case, we have a ratio which says sine theta is what? Sine theta is basically a ratio of opposite over hypotenuse, correct?
Yes, sir.
So when you say sine theta is half, it really means if this is the angle theta, in that case, this side is 1 and the other side is 2. Is it okay? Hypotenuse?
Yes, sir.
And you found the third side, which will be equals to 2 square minus 1 square square root, 4 minus 1 square root 3, correct? You get this. And if you want to find what theta is, then you said, well, theta is equals to sine inverse of half. Is that okay? Use your calculator and then you figure out, well, in this case, it is equals to 30 degrees. Is it okay? Then you use your calculator. You also get this result using a special triangle. Let me use this third method. Special triangle. So this special triangle, if you draw this special triangle, which is, let me complete here like this. Let us say we have an equilateral triangle, means all are 60 degrees, correct? And let's say each side is 2. Then if I drop a perpendicular, in that case, what happens? Well, that side will be half of 60, right? And this side will be half of 2. So 1 and 1, correct?
Yes, sir.
Now you get a triangle which is very similar to what we had drawn earlier. You get the idea? And
yes, sir, because
you can clearly see that sine ratio 1 opposite side over hypotenuse is 30 degrees, correct?
Yes, sir.
So from special triangle also you can get the value theta equals to, so we know sine of 30 degrees is equals to half. Is it okay? So what we have done here is that we have make a connection. So we basically connected, right? So we connect our learning. We know what sine ratio is, right? So we have a trig ratio. We have a triangle, correct? Two connecting them. We also have special triangle, correct? to get the exact value. So that is what you did. And all this was done in a right triangle. So you always worked in right triangle. Is that clear to you?
Yes, sir.
But now think that it is not a right triangle, right? So if it is not a right triangle, then how will you find sine ratio or sine theta? For example, if I give you a triangle which is kind of like this, now this is not a right triangle, right?
Yeah.
How will you solve this triangle? That's the whole thing, right? So we are saying, well, this angle is something, but this is not right triangle. How will you solve this? So how do you solve? When it is not a right triangle? Because all the trigonometric ratios said what? Let's write down SOHCAHTOA. Opposite over
Over
hypotenuse,
the news. Yeah.
cosine
It's
adjacent over hypotenuse, tan opposite over adjacent.
over adjacent.
So if it is not a right triangle, how will you get hypotenuse? You will not get hypotenuse.
No, sir.
So you cannot find sine theta and cos theta, correct?
Yeah.
So that is the difficulty. And that is where we get to sine law and cosine law. Is it okay?
Okay, sir.
So let's first understand sine law. So if I do not have a right triangle, let's say I have a triangle ABC, which is not a right triangle, no problems. I can always draw up a perpendicular, no?
Yeah.
And make two right triangles. And make two right triangles, correct?
Yes, sir.
So that ways I could solve. Now, how do I find sine theta and all, right? Let's say this angle is sine A. So let's say the sides are, in general, we write sides as A, right? So opposite to C is C, correct? And
Yeah.
this long side is B. B
B.
is the whole length, correct? Now let us say this B is divided into two small components, X and Y, because we have dropped a perpendicular, correct?
Yeah.
And let us say height is H. In that case, what is sine A, or what is this? Sine A can be written as what?
Sine A
Sine
can
A
be.
can be written as H over C, right?
Yeah.
So from here, I can write what H is. So H is C sine A, right? Cross multiply. Is that step clear? Sine
Yes,
of
sir.
angle A is opposite side over hypotenuse C. And from here, I can cross multiply and get what height is. Now look at the other triangle. What is sine C?
It would be it would be H over A.
And that means H is what? A sine.
A sine.
Now height is same, right? So H is equals to C sine A, which is also equals to A sine C. Do you see that?
Yes, sir.
So I can cross multiply and write this as sine A over A is equals to sine C over C, correct? Similarly,
Oh,
you see that? Similarly, I can do the other two triangles and also say that this is also equal to sine B over B. Is it okay?
yes, sir. So
This is sine law.
I understand like the sine A equals a sine A divided by A equals sine B over B and sine C over C, right, sir? But I never really understood how you've gotten it.
How
Because
to
if you look
derive
at it in a acute triangle, you can easily identify which one is which by just the two sides and angle.
Correct. So this is always a constant, right? This is always a constant. And this equation can also be written in the reverse order. That is to say, I could also write this as A over sine A, right? Equals to B over sine B. equals to C over sine C. Either way, we could write this equation.
And it doesn't matter, right, sir? It doesn't matter because either way you do it, you still get
Constant.
the same
It's a
answer.
constant, right? It's a constant. So that is the beauty. So we can always use this equation to solve any triangle. Now I said any, but not really. Let me show you why. So we know now what is sine law, right? Can you tell me what is sine law?
So sine law is basically used to find out the acute triangles. So it's like a constant ratio where you can see sine over the length of a triangle and different parts of it.
Yeah. So I will tell you which triangle it can solve, which triangle it cannot solve. Okay. That is the second part. Now, to solve a triangle using this ratio, let me sketch one triangle here, right? Let's say ABC. So what is necessary is to have one combination of angle and opposite side. Do you see that?
Yes, sir.
Only then the triangle can be solved. That means if I have two sides and an angle, you see that? So if it
Yeah.
is angle, side, side, I could do that. Is it okay?
Yeah.
If I have two angles and a side, I can do that. Correct?
Yeah.
However, if I have three sides,
Then you can't use it.
then you can use it. So in that
You would
case,
have to use cosine law, right, sir?
yes, we'll take it in the next class. Or if I give you a triangle and included angle, two sides and the included angle, you see that? Now I do
Yes,
not
sir.
have this combination of opposite side. I
Yeah, so
cannot
you
use.
still have to use cosine law.
So for SSS and for SAS, I cannot use it. You get the idea?
Yes, sir.
But for the others, I can use it. So sine law can be used if I are given one angle, two sides, or two angle, one side.
Yeah.
That is very clear. Is it okay to solve the triangle?
Yes,
Is
sir.
it clear to you?
Yes, sir.
Let's take up an example. So let's say we have this triangle. Okay, so let's write down some values here. Let's say 40 degrees, right? Let's say, so we want this combination, right? So let's say this side is 6. So we have one angle and one side. Now, if I give you any other side, you can solve the triangle. For example, if I say, well, this side is 10, then can you find other angles and sides? Can you do it?
Yes, sir.
Do.
So if it's A, B, and C, then it'll be sine A.
Yeah, calculate. It is in degrees, okay?
Yes, sir.
What do you get?
40 degrees. Sir, when I did it,
Get an error?
yeah, it keeps on showing error.
For me also. So this value doesn't work, right? So for this value, it will give you an error. So maybe I have to reduce this size to 8 and then try. Is it okay?
Okay, sir. I thought when I did it, I thought I was doing something wrong.
No. Yeah, that side was too much. So probably you cannot form a triangle with that. Is that okay? So let's
Okay,
change
sir.
this to 8. Now what do you get?
You get 59 degrees.
So you get 59 degrees, let us say, okay? And then you can, yeah, so let's do 8 divided by 6 times sine of 40, which is 0.85, and we'll do shift sine inverse of the answer, and we get, as you said, 58.9, 59 degrees. So we have 59 degrees here. Is it okay?
Okay, sir.
So now once you have 59 degrees, you can find the other angle. Angle C will be equals to 180 degrees minus 40 minus 59. What do you get? And you can also find the side C, right? C over sine of that angle is equal to 6 over sine of 40. And C equals to, this is 81 degrees. Oh, this is 81 degrees here.
I got 9.2, sir.
Yeah, 81 degrees. So sine 6 times sine 81 degrees over sine 40 degrees.
What?
You got to how much?
I
9.2?
got 9.2.
You understand how to calculate? Yeah, so this
Yes, sir, I understand.
9 point. Is that clear to you? So
Yes,
if
sir.
you are given this kind of a figure, you could figure it out. Now let's take up another example, right? So let's just make another triangle. And this time we'll work with 2 angles and a side. Is that okay?
Okay, sir.
So let us say we have these 2 angles, 80 degrees, and let's say we have this angle as 65 degrees. And we know one side, and let's say this side is 10. Let's see, how do we solve this triangle? So let's label A, B, C, and let's try to figure out what is this side. So this side will normally treat this as B, correct? Now,
Yes, sir.
first thing is you have to find the missing angle. So that missing angle C is equal to 180 degree minus 80 minus 65. Is okay? 100 minus 65. 35.
I got 35 degrees, sir.
Now you can find all the sides. Is that clear to you?
Yes, sir.
The B over sine of 80 degrees equals to 10 over sine of 65 degrees, and that should be equal to C over sine of 35 degrees, right? So if I solve these two equations, first two, I get one value. B equals to 10 sine of 80 degrees divided by sine of 65 degrees. And then if I solve the other two, I get C as equals to 10 times sine of 35 degrees divided by sine of 65 degrees. Is that clear to you?
Yes, sir.
So we have solved the triangle completely using sine law. Is that clear?
Yes, sir. And when I did it, I got B as 10.9 and C as 6.3.
Perfect. We'll go with these values. It makes sense. B as 10.9 because the angle is bigger. It makes sense. And 35 is smaller. So 6.3 makes sense. So I'll say correct. Good job. So, we have applied the sine law and solved some questions which were not having the right angle. You get the idea.
Yes, sir.
For the cosine law, I'll not derive the formula for you, but I'll give you cosine law.
Sir, just in case I want to see if this is correct, but for cosine law, right, sir? You
Yeah.
have two formulas. It's basically one formula, but rearranged for
Yes,
angles
yes,
as
yes.
well, right,
Yeah.
sir?
Tell me. Yeah, yeah.
So for sine law, I think it's if we did A, B, C, it'd be A square equals B square plus C square minus 2BC cos of A.
Correct.
And
Yes.
then for angle, it's like equals cos inverse and in square brackets A square
So
minus
let's
B
rearrange.
square minus C
You're
square.
right. Let's rearrange. We'll bring 2BC cos A to the left side, and we have B square plus C square minus A square, correct?
Yes, sir.
Of cos A equals to B square plus C square minus A square over 2BC. Is that okay? So
Okay, sir.
A is equals to cos inverse, as you're saying, of B square plus C square minus A square over 2BC. Perfect.
Sir, I thought it was that when you do it, it's A square minus B square minus C square over negative 2BC.
No, don't put negative. So,
Oh,
yeah. So basically, if you look at the triangle, let's look at the triangle and relate the formula. Is it okay? So let's relate the formula ABC once again. Our triangle, sides ACB. And clearly, we are solving, let's say, if we are solving for this, that really means we are given two sides and included angle. Do you see that?
yes, sir.
So C and B is given to us, C and B, and angle A is given to us, and we can find the opposite side. You get the idea.
Yeah.
So two sides and included angles, multiply those two sides, that comes in the denominator, to find the side. It is like this. Is that okay? So
Yes, sir.
that is your cosine law.
Okay. And sir, after we find out whatever, let's say we're looking for A, right, sir, we can then use sine law as well to find out all the other angles, right?
Yes. Because once you find A, in that case, you have satisfied this condition that we know angle and opposite side, so you can use sine law. Sine law is easier to use. So most of the time, you have to apply cosine law first and sine law later. Is that clear to you?
Yes, sir.
So that is the trick. I can actually share with you some questions. So I'll stop sharing this screen. I'll share with you one of my lessons on this. So let me share with you one of my lessons on trigonometry. We are looking into sine and cosine law. Okay, sine law first. So here are a few questions for you based on sine law. So we have both questions on sine law and cosine law for you. So Rohan, can you help me solve these questions?
Okay, sir.
Question number 1. The perimeter of an isosceles triangle is 100 meters. Find each side length if obtuse angle in the triangle is 100 degrees. So sine law can be applied to any triangle provided we know
Yeah.
two angles and a side, or one angle, two other sides. Is that okay?
Yeah.
So how will you do question number 1? Tell me. Perimeter of an isosceles triangle. Isosceles triangle. You understand the key word here?
Yeah.
When
So
you make
no, so two equal sides.
two equal sides, right? So let us say these two sides are equal. Let's call them as x, right?
Yeah.
And y. This is perimeter of isosceles triangle is 100. Find each side length if obtuse angle in the triangle is 100, right? So
Yes, sir.
if we cannot have two obtuse angles, correct? Because
Yeah.
sum is 180. Obtuse means more than 90. So that means that angle is 100. So the side y is the longest. Now the other two angles are what for you? 180 minus 100 divided by 2 means 40 degrees, correct?
What?
And we are given that x plus y is equal to also 100. Is that okay?
100. Yeah.
So we have their ratio, correct? So we can say 2x,
Plus
we can say
y.
what is y? 2x plus y equals to 100. Or we can say y is basically 100 minus 2x. Is that okay?
Yes, sir.
Can you find each side and tell me the answer now? Yes.
For each side, sir.
Now, how will you find x and y? Tell me.
So we
So,
already know the angles, right, sir? All the
yeah, so
angles.
y over sine 100. Y over sine 100, I want to write, and I'm writing what 30. Y over sine 100 is equal to x over sine 40. Is that okay?
Yes, sir.
And we know y is 100 minus 2x, correct?
Yeah.
So we'll write this as 100 minus 2x over sine 100 equals to x over sine 40. Is it clear to you?
Yeah.
So find the value. What is you can what is 100 minus 2? What is 1 over sine 100?
1 over sine 100.
Yeah.
It would be 1.015.
Okay. So you could cross multiply and then do it so we can say 100 sine 40, correct? Cross multiply minus 2x sine 40 equals to x sine 100. Is it okay?
Okay, sir.
Isolate. So bring this to the other side. So 100 sine 40 degrees equals to x sine 100 plus 2x sine 40, correct? So 100 sine 40 degrees, x is common. So we have sine 100 plus 2 times sine 40 degrees. Is that okay? So what
Yeah.
is x equals to? X is 100 sine 40 degrees divided by sine 100 plus 2 sine 40.
Okay, so you're basically dividing it in brackets, right, sir?
Factored it and then, so it's a tricky question. It's not a simple question. So all these questions which I'm discussing with you, they are slightly difficult. You get the idea.
Yes, sir.
Okay, I think I have the solution also here. So let's go through this solution. So as you can see, let's look into this solution. We have already got the result, right? Let's go through the solution. So first, what are you going to do? As shown here, we are going to sketch the diagram, correct? We are
Yes,
given
sir.
isosceles triangle, obtuse angle being 100 as shown here. So the other angles will be 180 minus 100 divided by 2, which will give you 40 each, correct? Now we have applied the sine law, x over sine 40, this ratio, 100 minus 2x over sine 100, cross multiply and isolate x. And when you calculate, you get the value of x as 28.3. And now substitute this value of x and get the y value, right? 100 minus 2x, correct?
Yeah.
And so you get the y value. And that is how you're going to solve this particular question. Do you find it interesting?
Yes, sir.
Very difficult question based on sine law. Now, I would like you to do question number 2. Oh, this was it, right? This was it. Oh, there are a lot of stuff here. Okay, question number 2. Can you please read the question, try it out?
So find the value of x to 3 decimal places in the figure below, given below.
Correct. So now it is a quadrilateral. So it is not just solving a triangle, correct?
Yeah.
Any shape. Because what you can do? You can make 2 triangles, why not?
And then you can just do solve for x, right, sir?
So first you solve for y, you can solve this triangle, right?
Yeah.
You might have to use cosine law in this triangle, correct?
Yeah.
Once you know y, then you can go for another cosine law and get the values of x. So this is basically based on cosine law if I split it in this fashion, correct?
Okay, sir.
You get the idea.
Yeah.
Try the next question. Please read question number 3.
To measure the height of a cliff, A surveyor measures the angle of elevation to the top of the cliff to be 50 degrees. When the surveyor moves 20 meters closer to the base of the cliff on a level ground, the angle of elevation increases by 15 degrees. Find the height of the cliff to the nearest tenth of a meter.
You understand?
So basically, sir, by looking at the equation, it seems that like where his beginning point is at, he is at 50 degrees. Then he moves a little bit closer, and then the thing changes. So it's basically like the other question that we did
We
before,
did
right?
yesterday. Perfect. Exactly same question, right?
Yeah.
And that is how surveyors actually find height of many objects. Is that okay? Even mountains. Height of all the mountains they have done in this fashion. They'll take an observation from one point, then go, let's say, 1 kilometer and take the observation from the other point.
Yes, sir.
So, but they have to have a level. Question number 4. Can you please read that?
A harbor patrol officer is standing on a 75-meter tall lookout tower and sees two boats anchored below his position. The angle of depression from his position to the boats is 44 degrees and 31 degrees. If the angle between the two boats is 110 degrees, calculate the distance between the two boats.
Correct. It is also similar to yesterday's question. Only
Yeah.
difference is yesterday we took 90 degrees as the angle between the two boards, correct?
Yeah.
Because we didn't know sine law and cosine law. Now, because we know it, it could be any angle. 110 degrees, for example, in this case. You get the idea. So you can
Yes,
also
sir.
solve this question, correct? From yesterday's knowledge.
Yeah.
Let's look into the solution of question number 2 first. Okay. We already seen solution of question number 1. Can you please explain me the solution of question number 2 from this screen?
Okay, so by looking at the equation, we were told that our objective was to find the x degrees on the trapezoid. So what we first did was it seems that like we applied cosine law to the triangle ABC. So what we
Yeah,
first
you
did was
made
we
this
divided the
diagonal.
triangle and
You made
labeled
the
it.
diagonal, so you have now two triangles. And
Yeah,
since we know side angle side, you'll apply the cosine law and find the opposite side AC, correct? Using the
yeah,
formula given, which you know about, correct?
yes, sir. And then we got our answers 5.965 meters. And from there, we input it into our cosine law to find x in degrees. So what we did was use cosine law of angle to help to get our equation for x. And by looking at that, we have got in 0.6644 degrees. And then from there, we did cos inverse of whatever we have gotten inside the bracket to get 48.36 degrees to find angle x.
Correct. So that is how you're going to do it, right? Next question, as you said, surveyor's question, correct? So this is how they measure the height of cliffs and mountains, even trees, right? So basically what we are doing here is, see, last time we used tangent ratio. You remember we used tangent ratio to solve that question, correct?
Yes, sir.
Now we know sine law. So when I did first observation, it was 50 degrees, and then it was 15 more, means 65 degrees, and the distance traveled is 20 meters. So this oblique triangle which I have, I know the external angle of 65, so it is equal to sum of two remote interior angles, correct? You remember
Yeah.
that? And therefore, the angle at D is 15 degrees. Do you understand?
Yes, sir.
Now we are solving this particular small triangle, and in this triangle, we are trying to find the side BD using sine law. Correct?
Okay. Yeah.
So BD over sine 50 degrees, which is opposite to it, equals to 20 over sine 15. So we found BD as by cross multiplication as 59.195. Once you know
Yeah.
what BD is, you need to find the opposite side, which is the height. Again, use sine ratio. Opposite over hypotenuse.
Yes, sir.
So from here, you can find height DC as 59.195 times sine 65. And you get your answer 53.6. Is that clear to you?
Yes, sir. So what you did was whatever you have found out from using sine law, you input it into the second triangle to get whatever DC was between.
Correct. Second triangle is a right triangle, so we know the hypotenuse and we need to find the opposite side. We use sine ratio to get the answer, correct?
Yes, sir.
Good job. Next question, please. That is a 3D. So, Rohan, whenever you get this kind of a question, you have to carefully make a diagram exactly like what I have done here. You get the idea?
Yes, sir.
Yesterday also I was talking to you about this particular diagram. When it is 3D, do you see these lines parallel, right? So this is like the lake or river, right? So we are looking at the same angle. So you understand how we have to sketch it. So angle of depression is same as angle of elevation as shown here, correct?
Yes, sir.
Once you have a diagram, it is easy. So can
So,
you
sir, when
explain?
you're making these diagrams,
Yes.
right, sir, like these 3D diagrams, like, do you have to, how much did you have to envision it to make it like
Yeah,
a
you have to
3D
have a vision.
diagram?
Vision, see, 3D diagrams make this vertical. Look at the corner of your room. You get the idea? Look at the corner of your room. You have a wall
Yes, sir.
there and the floor here. Do you see this floor? Do you see this floor on the corner of your room? That is the
Yeah.
3D diagram. You see that?
Yeah.
You could do this and make your 3D diagram. You get the idea. But in
Yes, sir.
practical, I do not make it horizontal because it looks like I make it like this. It gives you depth. You see the difference in the two lines.
Yes, sir.
And how do I make it show this is 90 degrees? You see how I show 90 degrees? So this side which I'm drawing is parallel to this side. Do you see that parallel sides?
Yes, sir.
And the third side is parallel to this. It is like when you sketch isometric views, you remember all the lines will be only in these three directions. You get the idea.
Oh, okay. Yes, sir.
All the lines will be in these three directions except for line of sight. Except for line of sight. How do you look at? You can look anywhere, right?
Yeah.
So the line of sight in this case is this. Do you see that diagram here?
Yes, sir.
But the angle is depression. Again, it has to be parallel. And therefore, the angle is this angle. You understand? Which is equal to this
Okay.
angle.
Yeah, I see, sir.
If you visualize like this, then it is very easy to get 3D questions. Very easy.
So it's basically like a mixture of like mainly like angles and then like looking and envisioning what is happening and where you can be placed, right, sir?
Yes. Very good question. Once you make this diagram, it's not very difficult. And how do we make it more difficult for you? We say, see, can you please read the question, Rohan?
So harbor patrol officer standing on a 75-meter tall lookout tower and sees two boats anchored below his position. The angle of depression from his boat to the boats is 44 degrees and 31 degrees. In the angle between the two boats is 110 degrees. Calculate the distance between the two boats in meters.
You understand now the whole sketch, correct?
Yes, sir.
So once you have the sketch, you know that this height is given, this is given. You can find that distance on the river surface, ground. You get the idea.
Yes.
From one triangle and the other distance from the other triangle. We are talking about solving the vertical triangles, correct?
Yeah.
Once you know two sides and included angle, apply the cosine law, get the distance. This is the cosine law distance. Is that clear to you?
Yes, sir.
So see, simple 3-4 steps and you have your answer. That is the power.
I actually understand now, sir, once looking at the diagram. Because when I was envisioning in my head, I was wondering where each one is going to go.
That is so true. It takes time, but once you understand, you can easily do it, right?
Yes, sir.
Correct. So I like you to try more questions based on sine law and cosine law. There are many in this file. These are more difficult ones. Okay, but they deal with bearing angles. Okay. Can you please read this question?
Anil starts his morning walk on a level ground along the hill. He walks 140 meters at a bearing of 20 degrees on the level ground and then turns right at an angle of 140 degrees to climb the hill. The angle of elevation of this path is 15 degrees. He walks for 120 meters to reach the top of the hill. From there, he can straight go down the slope to his starting point. Determine the shortest distance for him to walk to reach the starting point.
Very difficult question. Now, so I've drawn a diagram for you to understand like how the situation could be, but that could be your homework and exercise to do. Is that okay?
Okay, sir.
I'll also share with you the solution so that you at least know the answer, if not anything else. And then when you're trying, you're sure that you got the right answer. Get the idea, correct? I'll upload this
Yes.
video. The answer is already given to you. The shortest distance is found to be 96 meters. Okay. Now, how will you solve this question? This is what you have to think. Is it okay? There's another
Yes, sir.
very beautiful question on sine law. And this is like whole lot of sine law from my book. Okay. Hundreds of questions here on sine law itself. Is that clear? So
Yes,
those
sir.
are the solutions, and let me just share with you. Now, but these are difficult questions, right? Which you might encounter soon, next year, grade 11, right? You see these questions? These questions are all solved using sine and cosine law. They're pretty difficult, and they are very common in competitive exams. You have seen these figures in competitive exams, correct?
Yes, sir.
So sine law and cosine law is a very important chapter for you. These are simple ones, straightforward. Since we have given you the diagram, correct? You can easily now solve the diagram using sine law and cosine law. It becomes difficult when the diagram is not given to you and you have to sketch it. Is that clear to you?
Yes, sir.
I'd like you to read question number 20, please.
A line from the point P 30, 0 intersects the circle x squared plus y squared equals 169 at points A and B. Determine the length of the chord AB if the line makes an angle of 160 degrees with the positive x-axis.
Correct. So at this stage, what are we doing? You learned about circles. You remember equation of circle, x square plus y square equals to
Yeah,
r square.
R square.
So 169 is 13 square. And so we know the radius is 13, correct?
Yes, sir.
So you have to apply or connect what you have already learned with the new things. You know about circle, you know the radius. Therefore, in this particular question, you know the radius. So you know O to B, correct? And you know O to A. Two sides of this triangle are known to you. The third side is what you need to figure out, correct?
Yeah.
Which is the chord. Now, and if you get this angle in between, then you know the chord. You can apply the cosine law and get the answer. You get the idea. So from our learnings, we have to visualize how do we find a solution to the question. That is critical thinking, correct?
Yes, sir.
Now we need to basically find this particular angle, right? Let me just enlarge this. If it can be, it's better, right? Let's just bring it. Oh, good job. Do you see this figure now clearly, correct? So we are sure that this 169 means the radius is 13. So I've written this isosceles triangle with 13 radius very clearly, correct?
Yes, sir.
The point which is given to us as 30, 0 means the horizontal distance is 30 because that is the x value, correct?
Yeah.
So we know O to P distance is 30 for us. Is that clear to you?
Yes, sir.
And in this particular thing, we are given 160 degrees as this angle made by the line chord, correct?
Yeah.
Since I know that is 160 degrees, I know the small angle should be 20 degrees. 180 minus 160.
Yeah.
Now I can find the other angle. You see that point?
Oh, yes, sir. I see.
And once you know this angle, in that case, you can solve using cosine law. I like you to now attempt this question as a homework. This is a very important question. We connected a couple of things here. One more concept is connected here, which is you could find from the ratio of chords also. but with the trigonometry which you have learned, you can find the solution still. Okay, no problems. Correct?
Yes, sir.
How? You know this side is 30, you know this side is 13, and you know this angle. So you can solve the big triangle using sine law, correct?
Yeah.
So A to P over, we can actually, because we know two sides and an angle, correct?
Yeah.
So you can find first angle A and then you can solve it. Is that clear to you?
Yes, sir.
So that will be your exercise. Correct?
Yes,
Let
sir.
me write down. You can find sine A, correct? Over opposite side being 30 equals to sine of 20 degrees. This is 20 degrees, right?
Yeah.
Over 13. So you get angle A, correct? Angle A is equals to angle B, and therefore you get the angle at O also, correct?
Yeah.
Once you know angle A, then you apply cosine law, right? Because the case is SAS. So you apply cosine law. Is that okay?
Okay, sir.
And find the solution. So one of the very beautiful question which you'll come across on this particular topic. I think we can end the class here. Okay.
Yes, sir.
So you've seen some very good questions from my book. Hope that helps. Similarly, this question I've seen many times in grade 9 EQAO test also, and later on in Waterloo exam.
Which
This
one, sir?
question,
Question number 21 or
yeah,
22?
21.
Oh, okay.
And even this question we have seen in Olympiad. Okay, this question is from Olympiad.
Oh,
So try these questions as an added exercise. So I'll stop sharing the screen now. We'll conclude. Oh. So today, what did you learn, Rohan? Can you summarize?
so today I've learned about cosine law and sine law and how I can use and see cosine and sine law in the real world activities. And also looking at equations and seeing how not only can it be shown in only triangles, but you can use different shapes and solve it as well. And looking at 3D models and real life examples like the height of a hill and all of them.
Perfect, perfect. That's very good. So we'll continue from here. Okay then. All the
Yes.
best.
All right. Goodbye, sir.
Bye. Thank you.